Bismillahirrahmanirrahim. Welcome to MIT. Today we will solve some of the problems of the topic kinematics. The first question I have picked up from paper 0606/11. That means it's an additional mathematics question. The first question we are going to solve is question number 10. Question number 10 says, in this question, all distances are in meters and time t is in seconds. A particle P is at a fixed point O at time t is equal to 0. The velocity v of p is given by v is equal to 3 sine 2t for t is greater than or equal to 0. Question number A says, find the exact value of t for which the velocity is 0 for the first time after p leaves O. That means this is our clue words, that first time, not at the beginning. That means the second time. So we will find the second value of t. Let's write, they told velocity is 0, so v is equal to 0. V is equal to 0, and v is the function of v is 3 sine 2t equal to 0, or sine 2t is equal to 0, or 2t is equal to sine inverse of 0. And we know sine inverse of 0 means 0 or pi. 0 or pi. When x is equal to 0 or pi, then the function value of the function gets 0. That means here t, instead of x, we are finding the value of t. So when t is 0 or pi, means the graph will look like this. Okay, suppose this is our graph. So sine curve will look like this. It will be 0 at the beginning and at this stage. At this stage we know this is actually pi. Okay, so sine curve is this. From the curve, if you can find it out, it will be easier and convenient to explain. So we know sine is 0 at the beginning as well as when it is at pi. So what have we got? That 2 pi or t is equal to, if we transpose this 2 to the right side, it is going to be 0 or pi over 2. Okay, they have told us to find the first time. Look, this is the clue word of this question, that first time, not at the beginning. We know at the beginning here t was 0 when it started. Then the second time is, this is the point when it came back to 0. So we will choose the second value. Hence t is equal to pi over 2. We are ignoring the first value because it has started from O or 0. So what is the necessity of finding O? They asked us to find the second value, this one. So our t is actually pi over 2. This is how you will solve this question. Next question says B. Next question is B. Find an expression in terms of t for the displacement of p from O at time. So we have been given the function as velocity, I mean v. Okay. Then from this function, they have told us to convert into displacement. Whenever the function v is converted to displacement, we will have to do integration. So we will find the integrand of v. Let's start the solution. So our v is actually 3 sine 2t, 3 sine 2t, and we are going to integrate. The integration notation, v dt over, we can just isolate 3 at the beginning, 3 sine 2t with respect to t. So this is actually the integrand of velocity is actually the displacements, and the notation for displacement is actually s. So we will write s is equal to, and you know how to do integration of sinusoidal graphs or functions. First of all, we will divide the coefficient. 3 will be divided by this 2, And if sine is integrated, it will be negative cos 2t. For better understanding, you may watch the videos I have made on integration and differentiation. Integration is the reversal or antiderivatives or reversal of differentiation. And well, so after integration, we have got that negative 3 over 2 cos 2t. Then we should not ignore that constant digit, because at the beginning we don't know how much distance was it traveled before we are doing this calculation. Okay, so constant value c is to be obtained in case of integration. It should not be ignored. If you ignore, then it's actually mathematically wrong. So let's find how much was the distance it traveled before it leaves O. Let's go back to the question again. The question says that particle P is at a fixed point O at time t equal to 0. At time t is equal to 0. That means when t was 0, there was no velocity at all. Sorry, there was no displacement at all. Means s was 0 at the beginning without having any distance or displacement. It started moving onward. So that means, in short, s is equal to 0. Displacement is 0 when t is also 0. So we are going to substitute these values. We will write t is equal to 0 when s is also 0. So we can write 0 is equal to, not 0, we can write the left side, right side on the left, negative 3 over 2 cos 2 into t is 0 plus c is equal to s. S is actually what? 0, or negative 3 over 2, and you know cos 0 is equal to 2 zeros are 0, and cos 0 is actually 1, we know. 1 plus c is equal to 0. So ultimately, what are we going to get? We are getting, since c is equal to, if this portion is transposed to the right side, it is going to be positive. It's 3 over 2. So our constant value is 3 over 2. That means when p started moving from origin, actually the distance at that moment, at that instant, was 3 over 2 meter. Now we can easily write our displacement expression. What was our displacement expression? It was s is equal to, this is our expression, s is equal to negative 3. So we can write, hence s is equal to negative 3 over 2 cos 2t, and see the constant value we have obtained is 3 over 2. So this is the expression they asked for. So what have we learned from this solution? Whenever velocity is given, and from velocity, if we find displacement, we will do integration, and if we find acceleration, then we will do differentiation. So velocity is look, it's very important. For acceleration, we will find the derivative, and for displacement, we will find integration. Okay, integrand. So these 2 points again I am repeating. For, let me write this. So please keep this in mind. For acceleration, you will have to find dv over dt. Means v will be differentiated, derivative of v should be obtained for acceleration. And for displacement, you will have to find the integrand of v, integrand of v dt. So these two are very important part of our learning, that for acceleration we will find the derivative, and for displacement we will find the integrand, or we will undergo the integration. Let's see what the immediate next question says. The next question C say, find the distance traveled by p for 0 until pi. That means the value of t will be, the domain is here from 0 to pi. So for distance, we have already come to know that integration is the distance. Let's see how the graph look. Our function was 3 sine 2t, velocity function, not the distance function. Velocity, the 3 sine 2t. We will have to actually sketch the graph for better understanding. Otherwise, if you randomly start finding the distance using the integration, then you may make mistake. Then the result may not be the accurate. So let's see how the graph looks. Graph will be, suppose this is t second. Let it me extend more. Let me erase this one also. This is our horizontal axis, means t second, and on the vertical axis we will write v meter per second. Okay, v meter per second will like, or this is 0 or origin. Then let's see the how much is the amplitude. Amplitude, first of all, remember, in horizontal axis we'll write, suppose this is pi over 4, then pi over 2, then 3 pi, 3 pi over 4, then it may be pi. So when you sketch a graph, first of all we'll have to find the line of equation. Here actually constant digit line of equation is 0. Okay, that means there is no other constant value. So line of equation is as it is. Then we will have to find the amplitude. Amplitude is, look at this, this is not a actually sine x or sine t, it's a transformed function, transformed graph. So in case of transformed graph, always we will have to first find the amplitude and the line of equation. So line of equation we have already obtained. Now amplitude is 3, so maximum value is going to be 3, and maximum, sorry, minimum value is going to be negative 3. Well, since this is a transformed graph and there are two cycles, so instead of one cycle we will draw two cycles. Two cycle is for 2 pi, as we are drawing up to pi, our limit has been given as up to pi, so there will be one cycle. And maximum values, maximum value of 3, when will it be maximum? In case of this graph, maximum value will be pi over 4, and minimum value is going to be over here. And as there will be two cycles in whole of the 360-degree or 2 pi, here in 1 pi there will be one cycle. So our curve will look like this. This is 0 when pi over 2 is, pi over 2 is the value of x, it will be 0. Then over here, then it will go just like this. So this is how our curve. From the curve, what do we know? Look at this. This portion is above our x-axis. The this portion of the curve is our x-axis, and this portion is lying below our x-axis. Why have we of doing this complicated part? Actually, this is not necessary to be drawn, but for your better understanding, I am showing you that, look at this, when the value of x is or t is pi until 0 until pi over 2, this is above x-axis, means it will produce your positive value, but the portion which lies below x-axis will produce your negative value. Now if you try to integrate from 0 until pi directly or randomly, then your answer will not be correct. So partially, first we will find how much is the distance covered when t was from 0 to pi over 2, and then for the next phase we will find the distance traveled by the particle from pi over 2 until pi. So I think you have understood this. Let's start finding the value. We have already integrated. Let's go back to our integrated expression. It belongs to the previous page. Here we have integrated that. Our expression is what? Expression was, this is our expression, this one. S is equal to displacement is, S is equal to negative 3 over 2 cos 2t plus 3 over 2. So it is already integrated result. That means traveled distance. Just what we will do, we will use the limit. So let's write S1 equal to, we are writing over here, this is S1. I have already explained, we will solve this part by part. So S1 is equal to, let's write S1. Let me change the color of the ink. S1 is equal to, what was our integrated part? I mean, for displacement, the function was negative 3 over 2 cos 2t plus 3 over 2. Okay, and we have already come to know that this is our displacement function. So for displacement, as we have got this limit of t, so we will write negative 3, and here look at this, how much is our limit? First one is from 0 until pi over 2, pi over 2. So what is it going to be? It is going to be negative 3 over 2 cos 2t. That means 2, if we multiply 2 into pi over 2 minus cos 2 into 0, and outside that there remains 3 over 2. Let me write at the below of this. Well, then it is going to be negative 3 over 2, and cos pi, cos pi is equal to negative 1, because using your calculator you can come to know, or you can memorize also. Cos pi is equal to negative 1, and cos 0 is positive 1. Okay, and this negative symbol is actually this symbol. Okay, this symbol is the negative symbol, that's why I have used this. Well, then outside that there is 3 over 2. So ultimately what is it going to be? If we, let me write just over here, or just beside this I can write, let me zoom it out. If I write over here, it is going to be, so negative 3 over 2, and this is 1 and 1, it is going to be 2, and negative negative positive, so it is going to be actually 3, equal to 3 plus 3 over 2. If we simplify, it is going to be 2 over 2 3 is 2 3 is 6, 6 plus 3 9, so 9 over 2. This is one part only. This portion we have got the distance covered in the first phase from 0 to, when t was 0 to pi over 2. Now we are going to find the distance traveled in the second phase, and it is actually, look, the lower limit is pi over 2 and upper limit is pi. So let's write the same function. Let me write this beside the upper part. Well, so it is going to be S2. Let me change the ink. S2 is equal to negative 3 over 2 cos 2t plus 3 over 2. Well, then negative, and we have already found the limit is from pi over 2 until pi. Okay, this is our limit. Then it is going to be equal to negative 3 over 2. If we substitute the upper limit, it is going to be cos 2 pi minus cos 2 and 2 will cancel each other, then it is going to be pi, then outside that there remains plus 3 over 2. Okay, then what is it going to be? 3 over 2 into, let me write this inside a bracket, so cos 2 pi. Well, I skipped a symbol, that is negative. This is negative 3 over 2. So cos 2 pi is equal to 1 minus cos pi is minus 1, negative 1. So negative, negative, positive 1. And you can use the calculator to find this value. And outside this, there remains 3 over 2. Okay, then let me write this just over here. So ultimately, what is it going to be? Equal to negative 3. Negative 3 over 2 into 2 plus 3 over 2 means negative 3, negative 3, or if I elaborate, it is negative 3 plus 1.5. So what is it going to be? Actually, it is producing negative value, negative 3 over 2, negative 3 over 2, negative 3 over 2. Now at the beginning I have explained that as this portion, the second portion, this portion, as this portion is lying, this portion is lying below the x-axis, it will produce negative value. So we are searching for a displacement. Displacement can never be negative. How can we make it positive? There is an easy way. We will just use modulus symbol. Let us use this modulus symbol over here, 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 as well as there. Everywhere we are using modular symbol. Then we will choose the positive value. We don't need this negative value. So our displacement in the second phase is 3 over 2. Now we will find the total distance. Okay, for total distance we can write on a new page. Let me write the total distance. Total distance is equal to total distance equal to, first how much did we get? Let me see this. We got, the first distance was this. Look, this was the first distance, 9 over 2, and second distance was 3 over 2. 9 over 2 plus 9 over 2 plus 3 over 2. If we simplify, it is going to be 12 over 2, means 6 meters. 6 meter is the total distance covered by the particle. So the very crucial part of our learning of this question is, whenever we find, for finding distance or for any area, we must be very careful about this. Okay, in the graph, that's why I have drawn the graph taking much time. That means if you don't know the movement or direction of the graph, then randomly you cannot find the total value. That's why we choose that how much portion of that graph is above x-axis. Always the value above x-axis is produced positive, and the value below x-axis is produced negative, and we require actually positive values. That's why we have added this 9 over 2 plus 3 over 2, and ultimately we have got our total distance traveled is 6 meters. I think you have been all the confusions have been clarified so long. If we solve one more problem, I think it will be very easier for you to understand. The next question we are going to solve is actually this. You can see the paper 0606 13, paper is 13 slash May June 24. So from the same AdMath book, this is paper 13, and our question is, the question we are going to solve is actually it is question number 9. Let's start reading the question. The question says, in this question, all lengths are in meters and time t is in seconds. A particle P moves in a straight line such that t seconds after leaving a fixed point O, its displacement is s, which is given by s equal to 4t minus 4 cos 2t plus 4. First question says, find the velocity v of p at time t. So we have been given the function of s. Displacement is given. In the previous one, velocity was given and we converted back to displacement. Here displacement is given, we will move on to velocity. So we will write s is equal to, s is given, s equal to 4t minus 4 cos 2t plus 4, And already we have come to know that whenever we move or we convert s, I mean displacement, to velocity, then we will have to do differentiation. So ds over dt is equal to, here if the derivative of 40 is 4, and cos, derivative of cos is positive sign, and 4 will, these two will multiply it by the coefficient, and cos is going to be what, sine, sine 2t, and derivative of 4 is 0, which is unnecessary to be written. So derivative of displacement is actually velocity. V is equal to this 4 plus 8 sine 2t. That is the answer we are to write. So what have we learned? If displacement is given, then the derivative will be the velocity. If velocity is given, then integration will be the displacement. It's vice versa. Well, so for in the previous one, velocity was given and we found displacement. Forward we did integration. So whenever displacement is given and we move on to velocity, then we will have to find the derivative, means differentiation, or vice versa. Let's see the next question. Question number B says, on the axis sketch the velocity time graph. So this is velocity time graph for p for 0 until pi, giving stating the intercepts with the axis in exact form. So the first of all we should know that, look at this is our function. Okay, this is our, sorry, this is our function, and this is not a simple or original sinusoidal function. This is a transformed function. Whenever transformed function is given, first of all we will have to know the maximum value, minimum value, and the line of equation. So line of equation is actually 4. Look at this here, line of equation is 4 and amplitude is 8. So greatest value, maximum value is going to be 12. 4 plus 8 is equal to 12, and minimum value is going to be 4 minus 8 is equal to negative 8. So remember, whenever a transformed function is given, for drawing that graph we will have to know the minimum, maximum, and line of equation. First of all, line of equation is 4. So let's start a drawing. So line of equation is 4. Let's write here 4. Okay, suppose this one is our 4. Okay, this is 4, and this can be a dotted line because we don't need to show this, so it can be dotted line. This is actually line of equation. Now maximum value, okay, it is too higher, so let me draw a little bit lower. Suppose up to this it is 4, and the maximum value, so line of equation maximum value will be written later on. First you draw this dotted line. Okay, this is our line of equation. As we don't need to show this is not necessary, that's why we are using dotted line, not solid line. So maximum value is 4 plus 8 actually, because sine value of any cycle, whatever the number of cycles, total value will be, maximum will be 8, minimum will be negative 8. So positive 8 plus 4, it is going to be 12. Let us write 12 over here. It is 12 for maximum value, and minimum value is going to be a 4 minus 8 means negative 4. So if it is 4, negative 4 may be over here. Okay, negative 4. Then what will we do? We will have to write here for x-axis. Suppose as this is pi, last of all the upper limit of the domain is pi, we can write here pi over 4. Okay, let me write a little smaller in size. So this is, suppose this is pi over 4. Well, then next one will be pi over 2. So not so close, let me write this. First find the half of this. Suppose this is half, so this is pi over 2. Okay, then it is next half is going to be pi over 4. Pi over 4, pi over 4, then this is going to be 3 pi over 4. Well, as there are two cycles, so within pi there will be one complete cycles. Usually for original sine function, for 2 pi there is one complete cycle, but this is actually compressed function. So sorry, not compressed, it is enlarged function or enlarged graph. So within pi there will be one complete graph, complete cycle. So for one complete cycle, for maximum value will be over here and minimum value is going to be over here, okay, at this point. Then let me show you how to draw this. Suppose this is our minimum value, and our line of equation is 4, so the graph will start from 4, this, okay. After that it will be 0. Where is it going to be 0? This is our minimum value, so it will look like this somewhat. It may not be exact. Let me try to draw more accurately. It's not possible to be drawn 100% accurately without any instrument, but I'm trying to show you. It may look like this. That means, let me erase this part. It will look like this. It may pass through this. Not even that. If it is, yes, it may be something like this. So this is somewhat uh, accurate as much as possible I did. Well, now we should know, they have to look at this question. What does the question say? Stating the intercepts of the axis. Now y-axis we have already shown that here. This is the y-axis. uh, y-intercept has been shown here. But what about the x-axis? The other intercepts are, we know that here this is the point. We will have to show this point. Look, this point should be shown, and then we will have to show this point at what y is equal to 0. So for this we will have to actually solve this. Let us solve the function. The function is, what is the function we do have is 4 plus, so let's write 4 plus 8 sine 2t is equal to 0. We are solving this and finding the exact value of t or x, whatever. So 8 sine 2t, sine 2t is going to be, sine 2t is going to be negative 4 over 8. Okay, that means it's actually half. So 2t is equal to negative half. Sorry, so sine 2t is equal to sine inverse of negative 2 half. That means if we transpose this sign, it is going to be sine inverse of sine inverse of negative half. Okay, and sine is negative in either third or fourth quadrant, either third or fourth quadrant. Either this is the angle or this is the angle. So how will we find that 2t is equal to, actually half is in the basic angle is 30 degree, so it will be actually this with 30 plus 180 means 210. So pi plus pi over 6, the first one. And in the second one it is going to be 2 pi minus pi over 6, pi over 6. So what is it going to be? It is actually 6 pi plus 1 pi, that means 7 pi. 7 pi over 6 plus, it is going 12 minus 6 to the 12, 12 minus 1 is 11 pi. 11 pi over 6. If 2 is transposed to the other side, it is going to be, hence our t is going to be pi over 12, sorry, 7 pi over 12 and 11 pi over 12, 11 pi over 12. Let me write this 12 over here. 11 pi over 12 and 7 pi over 12. That means 7 pi over 12, if we convert it into degree, it is going to 1505. Okay, 105 degree, 105 degree, 105 degree. Another one is 12, 15, 165, 165 degree. So 165, look at this, our this point. Now this point is going to be 60. First one is 105, 105. This one is going to be 105. So here we will write 105 for your convenience. Actually I am terming it in degree. It's actually, you will have to write in this form, in radian mode. In radian mode it will be 11 pi. So this one is going to be 11 pi over 11 pi over 12, 11 pi over 12, and this one is going to be 7 pi over 12. This is 7 pi over 12. I need a lot of space to write, that's why I'm writing over there, but you must write over here at this point. Okay, you will write at this point and at this point. It may be closer to pi actually, because it's almost pi. So this here you will write, so 7 pi over 12, and the other one, as I have written, this is 11 pi over 12. So this is how you will draw the curve. First of all, what will we do? We will find the upper, I mean line of equation, this dotted line. Then the maximum value is over here. Okay, and then the minimum value will occur here. Minimum value is this. I cannot show you in exactly in accurate form. This is actually your minimum value. This is minimum value. If you use your pencil and scale, on paper it can be easily drawn, but on display it's very difficult to show more appropriately. So what have we understood from here? Actually, velocity time graph, always first of all we will have to find the, this is our line of equation should be drawn, and then minimum as well as maximum value. After that we will find this, through the solution we can come to know the x-intercepts. For x-intercept we will have to actually solve this, and uh, then as much as accurate it is possible you can draw it. I think it's sufficient for you to understand. Let's see what the next question say. The next question is page number 6. Okay, so the question says find the acceleration of p at time t. So let's write first the velocity. Velocity was v is equal to, we have already written it, 4 plus 8 sine 2t. From velocity we can convert to acceleration. So we can, for acceleration, velocity will be differentiated. Let's find the derivative of v. Dv over dt is equal to, if we differentiate this 4, it is actually 0, which is not necessary, and 8 will be here. If sine is differentiated, derivative of sine is cos, and these two will multiply. We know this 2 will multiply the function, and it is going to be cos 2t. That is what the acceleration at t. Hence our acceleration we can write as a is equal to 16 cos 2t. So from velocity, if we want to find acceleration, we will find the derivative, and derivative of the given v is actually 16 cos 2t. That is the answer we got. And what does the next question say? The next one is find the find the times when the acceleration of p is 0 for 0 until pi. So for acceleration is 0, simply we do have the notation of acceleration is here 16 cos 2t. So let's write 16 cos 2t is equal to 0. 16 cos acceleration is equal to 0. Okay, we are writing in this way. So it's 16 cos 2t is equal to 0. Well, that means cos 2t is equal to, cos 2t is 0. Cos 2t equal to 0, or 2t is equal to 2t is equal to cos inverse of 0. Cos inverse of 0, we know cos inverse of 0 is equal to 2t. Okay, cos inverse of 0 is equal, actually cos values are actually what, 1 0, -1 0 and 1 again. So here we are searching for 0. Here cos inverse of 0, here this is pi over 2, and again 0 is actually the difference between them is going to be pi. Okay, so when cos is equal to, I mean t is equal to pi over 2 or pi, then cos is equal to 0. So cos inverse of 0 is equal to pi over 2. First value is pi over 2 and the next value is pi. Using your calculator we can find this. Cos inverse of 0 is equal to this. Then our t is going to be, if 2 is transposed to the other side, then what is it going to be? Hence it may be the last step. 0t is equal to pi over 4 and pi over 2. That is what the answer we can show, as they have told, when acceleration is 0, find the time of t, find the value of t. So when t is pi over 4 or pi over 2, then acceleration becomes 0. I think it is now time to tell that you have understood far better than the first one. We have already solved two whole question. I mean, two solutions have been done, and through this you have learned a lot. If you have been benefited in the least bit, then I will be thankful and grateful to Almighty Allah. So pray for me so that Allah blesses me with all His bounties and mercies. Fi amanillah.